How to connect the nRF9160 feather to a self-hosted Mosquitto instance. One thing that's always tripped me up as an IoT developer is figuring out the best way to transmit data. There are many different kinds of radios and mediums. On top of that, there are different protocols to boot. Unlike an HTTP server, a device can connect, publish, and subscribe to topics. These topics then get sent to a broker and distributed to other subscribed devices. It also happens that MQTT on Nordic's nRF9160 is well supported. In this post, I'll show you how to connect the nRF9160 feather to a self-hosted Mosquitto instance. You'll learn how to generate your own certificates, and get a hang of how to test your connections. If you want to host Mosquitto, you'll need a server. Since Mosquitto is written in C, it's lightweight and can go almost anywhere. Plus it sips resources so you can install it on a budget VPS without much worry. That's where a VPS provider like DigitalOcean or Vultr comes in. Log in to DigitalOcean. If you don't have DigitalOcean and would like to support, click here to create an account. Make sure you import your public key. Otherwise, you won't be able to immediately use passwordless login. For the certs to work with Mosquitto, you'll have to set a domain to point to your VPS IP address. A CNAME or a record works. If you're unsure how to do that, here's a good guide. Note which subdomain you've used. We'll need it in a bit. I run my servers inside of a FreeBSD jail using Bastille. In this tutorial, we'll be skipping the jail part and focusing on getting the nRF9160 feather working. You should be set with a DigitalOcean instance, or similar, using FreeBSD. If you haven't done that yet, head back up to the Where to Host section. Next, to install Mosquitto on your droplet, run pkg install Mosquitto. If you're running something other than FreeBSD, this command may differ. apt-get install Mosquitto works on Debian-based systems. If you want the most up-to-date repositories, make sure you run sudo apt-add repository ppa mosquitto dev mosquitto ppa beforehand. Here's what the full output on FreeBSD looks like. All installed package configuration lives at usr, local, etc. Mosquitto. We'll need to edit Mosquitto conf in that folder to use certificates. Here's what it looks like. Before we can start the server, we'll need to provision some RSA certificates. We'll get to that in the next step. You can use EasyRSA to generate a CA server and client certs. These instructions come from this guide. For production, you should generate your keys and certs on an offline machine. That way your private keys are safe if your server becomes a target. Note, you will be prompted for a password at the build CA step. Make sure you keep this password handy. You'll be prompted for both the common name, i.e., your server name, and the CA cert password in the above step. Important, the common name needs to match the domain name of your server. Remember, we wrote that down earlier. Follow the same procedure as earlier. The only difference is that we're generating a client cert instead of a server cert. If you're using the configuration from above, it's already pointing to your server certificates. All we have to do now is start Mosquitto. Cannot start Mosquitto. Set Mosquitto enable to yes in /etc/rc.conf for use on a start instead of start. Nobody 82900 0.00.616352 6212 SSJ 117 0 minutes 0 seconds and 2 milliseconds USR local ESPN Mosquitto c/user/local/etc/mosquitto/mosquitto.conf Dealing with certificates on the nRF9160 feather is a two-step process. The first step is to load the certificates using the @client firmware. The second is to load the MQTT simple library with added TLS support. Let's tackle the certs first. To install our new certs, we'll need nRF Connect Desktop installed. You can download it by going here. You'll also need a custom version of LTE Link Monitor. You can get the modified version on docs.jaredwolf.com. First, install nRF Connect Desktop app. Then, Copy the LTE link monitor.tgz file to %USERPROFILE% nRF Connect apps local on Windows, or home nRF Connect apps local on Linux, macOS. Here's an example of where it is on Windows. Then, click Open next to the v1.1.1 version of LTE link monitor. It will also have local written underneath it. Then in the command box send at +cfn equals 4. This will shut down your modem so it's ready to upload certs. You can run at +cfn. To confirm your modem in that mode, make sure you set the security tag. In this case, I'm using 1234. This is an important identifier that you'll need later. Make it whatever you want, but I would avoid using 16,842,753. This is the default tag for nRF Cloud. You don't want to blast away your nRF Cloud certs. Copy and paste the contents of your ca.crt. nRF9160.crt and nRF9160.key into the boxes, in that order. You can easily get the certs by using cat on Unix, Linux. We'll be using the MQTT simple sample within the nRF Connect SDK repository. The full path is ncs nrf samples nRF9160 MQTT simple. We'll need to make a few edits to add full TLS compatibility. All the files are within the MQTT simple directory. The set the PDP context section is especially important if you're using a hologram SIM card, included with the nRF9160 Feather. If you are using a SIM that doesn't need it, you do not need this section. Open your serial terminal and double check that your nRF9160 Feather is connecting. You can also use LTE link monitor to view your progress as well, example below. We're almost there. You've configured your nRF9160 Feather to connect to Mosquitto using self-generated certificates. The last part is connecting another device to see if the nRF9160 Feather replies to a message. You can also use something like SCP if you're confident in your command line file transfer abilities. Then, open a terminal and run Mosquitto sub cafile ca.crt, certtest.crt, keytest.kq1dh testserver.geredwolf.com p8885t, my published topic, and Mosquitto pub cafile ca.crt, certtest.crt, keytest.kq1dh testserver.geredwolf.com p8885t, my subscribed topic m. Hello there. Mosquitto sub cafile ca.crt, certtest.crt, keytest.kq1dh testserver.geredwolf.com p8885t, my published topic, and Mosquitto pub cafile ca.crt, certtest.crt, keytest.kq1dh testserver.geredwolf.com p8885t, my subscribed topic m. Hello there. Client Mosq CCZ SKQKZM 404 sending published D0. Q1, R0, M1, my subscribed topic. 11 bytes. MacBook Pro downloads Geredwolf client Mosq QK8TMLJK0QRI4Z7 Duo received published D0. Q0, R0, M0, my published topic. 11 bytes. We've made it to the end. By this point in the post, you should have a Mosquitto server running and an nRF9160 connected. Now you can use your newfound skills to add more devices to your deployments and more. If you haven't had a chance to play with the nRF9160, you should check out the nRF9160 Feather. It has Nordic Semiconductor's nRF9160 LTE-M. NB-IoT plus GPS combo. Plus flexible power supply, external flash, and low power shutdown. Oh, and did I mention it's 100% open source? Learn more by checking out the campaign on GroupJs and Hacks to Launch. Learn to code for free. FreeCodeCamp's open source curriculum has helped more than 40,000 people get jobs as Text source: freecodecamp.org.